Awesome. All right. Well, again, thank you all so much for coming tonight. We're excited to have you here, and we're really excited for our speaker, Jeff Fry. Jeff is a senior partner developer on the JFrog partner engineering team, where he works with the JFrog ecosystem and partners to deliver innovative technology solutions. Previously, he was part of the partner and alliances engineering team at CloudBees, where he delivered partner integrations for Amazon, Microsoft, Google, VMware, and ServiceNow. Outside of work, Jeff enjoys traveling around the world with his family, racing karts with his son, and watching his daughter do front handsprings. And tonight he'll be talking about creating dynamic WebXR experiences with Angular and A-Frame. So without further ado, I will hand it over to Jeff. Thank you so much.
Yeah, thank Michelle and Jules. And thanks for having me on the San Diego JavaScript. Let me go ahead and share my desktop. There we go. So hopefully this will be a fun session here. What we'll be talking about is how you can use Angular in this virtual reality, augmented reality library called A-Frame to build these virtual reality and augmented reality experiences with your browser. So let's get started. So first thing, our community event organizer, Ari here, wants me to show you this. So this is a show notes page. Let me go ahead and put this into the chat. So on this show notes page, the slides that I'll go over will be here, as well as a chance to win the Star Wars Lego helmet set, which is pretty cool. And then you also have an opportunity here to get a t-shirt. So let me go ahead and put this in there. There you go. And then I'll be going over some code during this session. So this code is in GitHub. And I'll go also put this in the chat. There you go. All right, so it's like you already covered a bit of intro about me there. I did recently switch over to Senior Technical Alliance Manager at JFrog. So obviously I've been a developer for a really long time, but made that crossover to the dark side and joined the business development team. So very interested, doing a lot of work in TypeScript, Go, have a pretty extensive Java background. Big fan of motorsports, Formula One, obviously, like Michi mentioned there, I do some racing with karts with my son, so that's also pretty fun. My daughter does backflips. She's into gymnastics, competitive gymnastics, so that's always fun watching them both. And then also a big time virtual reality, augmented reality, mixed reality enthusiast. I have an Oculus headset, got all sorts of apps on the phone and playing around with that. So first thing I'm going to talk about is WebXR, but let's talk about the history of virtual reality and augmented reality and how that's come about, because there's been some starts on it, stops, a lot of hype, but it's slowly progressed over time. The first thing we probably want to talk about is, if you remember Oculus, if we can go all the way back to 2012 and the Oculus quick Kickstarter program that came about, there was a lot of hype around that. Shortly after that, they released some development kits. And if you remember these development kits, they were big. They sat on your head. You had like 20 wires coming off your head. So it looked pretty ridiculous. Shortly after that, you had Unity, Unreal development environments. So they were being already used to build 3D games. They had a natural fit to do virtual reality, augmented reality. And then the first Oculus consumer version released, but still it was pretty big. People would get sick. People would get hot with those things on. So it was still pretty cumbersome. And then if you remember Pokemon augmented reality, so people walking around trying to capture these monsters. So that was pretty crazy. And then right around 2014 to 2016 timeframe, you had the first virtual reality device API that came out, and this was WebVR. So this at the time was focused just on virtual reality. And this was extended to have a JavaScript API. It used a WebGL to do the graphics rendering. And it was pushed by Mozilla and Google. Then shortly after that, Microsoft put off HoloLens, you had Magic Leap and the mixed reality. And then phones started having support for it. So you had AR Core for Android. AirKit for iPhone. And then right around the 2018 timeframe, the WebVR API was migrated to WebXR. And this was to include the additional support for mixed reality and augmented reality. So WebXR supports both now. So now it's mixed reality, augmented reality, and virtual reality as well. And so just a clarification on the mixed reality and augmented reality part. So augmented reality is an overlay on your environment. This could be as simple as an info bubble that you see over your environment. It could be objects, but the distinction to mixed reality is mixed reality are objects and things in your world that you can interact with. So an example of that is if you place a ball, a virtual ball in your environment, and you'd be able to touch it and bounce it, that would be a mixed reality. And then obviously virtual reality is just a completely immersive experience, 3D experience. So let's move on here. So a little bit more detail on WebXR and the devices. So WebXR is a device API. It handles the inputs and outputs to support virtual reality, augmented reality, and mixed reality scenes. It allows you to write JavaScript, and I'll talk a little bit about those libraries. And so you can render these within these devices. So this just slide here kind of shows the browser and device support right now. Chrome supports it, so you can write your own JavaScript, and I'll talk about A-Frame as well to create these scenes. Microsoft Edge, unfortunately, Apple's a little bit behind. They don't have Safari support for it yet. There is a standalone WebXR viewer app that you can download to see some of these see some of these mixed reality, augmented, and virtual reality scenes. And then device support. All the Android Air Core compatible devices, Google Daydream, HTC Vive, Magic Leap, Micro HoloLens, Oculus Rift, the Samsung devices, and the Windows mixed reality headsets as well. So let's talk a little bit about the JavaScript support for WebXR. The first one I'll talk about here is Three.js. So Three.js has been around for a really long time, I think all the way back to like 2010. It was used to build 3D graphics. And so it was natural to have it support WebXR. So with Three.js, you can create scenes, you can create cameras, animation, put lights in your scene, create materials, shaders, objects, and all sorts of geometry. So what you're looking at here is a code snippet that creates a scene. First thing you'll see here is a camera's created, some orbit controls for navigation. We can create a scene, and then we start adding our geometry like a floor and a cube to that scene. So what I'll do is I will go ahead and jump over to my IDE and show you this exact one. Can you see my IDE just to make sure that, okay, great. All right, so this is that same code I just showed you there. What I'm doing is I'm bringing the Three.js library. You see here where I have my JavaScript in here. Again, this is where I'm creating a camera. I'm creating my orbit controls. I'm creating my scene. And adding in this cube, and adding in some lights as well. And again, this is all using the Three.js library. So now if I want to go ahead and view this in my browser, click on that. There you go. And there's the rendering using that JavaScript. Oops. So again, so that shows you Three.js. WebXR support for Three.js came in 2018. So you'll be able to do this using Three.js. Now, when we take that at a higher level, we have a new library called A-Frame, which is an HTML-based library. Behind the scenes, it's using Three.js. So the advantage of using this library is you can use HTML tags with certain component properties and be able to create these 3D scenes. It's an entity component system in that you create these HTML tags called entities. And by adding certain components that control behavior, appearance, you can create 3D objects. And so what I'm going to show you is an example of this A-frame. Jump back to my IDE. So you can notice the difference here versus using the Three.js and all the JavaScript. You have now using A-frame library, a lot of that's been abstracted away into these A-frame tags. So I've created an A-frame scene. So this is the tag for scene, a camera, and a box. And so if I go ahead and view that in the browser, and you get the similar object in the scene. But what you'll notice is that A-frame automatically has the WebXR support. So you'll also see a virtual reality button here. So if you had a virtual reality headset, you'd be able to view it that way. On a device that supports augmented reality, you'll also have a similar button as well. What I'm going to do right now is take you to the A-frame website. And it has a library of some of these experiences here. So this is aframe.io. I'll put this in the, oh, I see a question in the chat. No Firefox. I think about 4 or 5 months ago when I created this, there wasn't Firefox support. There may be now. I know they were working on it. I just posted in the chat there the link to this A-frame website. And in this gallery over here on the left, you have some several examples of scenes that you can create. I'll click on this model viewer one. So here's an example where we're creating a triceratops using a 3D model. So A-frame supports the bunch of different 3D modeling types. GTLF is a common one that's used. We can take a look at the source here, which there we go. So again, we're just pulling in the A-frame library here. There's some supplement libraries. And then really it's just creating a scene like you saw before. They have a tag for assets that you use to include different objects. And then we're including that triceratops in here. So I'll jump back here. Again, you can view this in augmented reality or virtual reality if you have that device. One other cool thing in the development of these scenes is you have a visual inspector that's automatically included in that library. So I can click on this visual inspector and get a development-oriented view of that scene. I can see all the A-frame tags that were used. I can move around, scroll around. Also, what I can do is I can take an entity, make changes to the attributes and see those happen in real time, or I can click on one. It highlights it here, and I can start moving it around and it updates in real time. And so this is a great way if you're working on a scene and you're having difficulty trying to place objects and can't figure it out. You can automatically go into this inspector view and be able to make updates. Okay. Oops. So that's a quick overview A-frame and how it works. Let's go into a little bit more details of the A-frame entities, primitives, and components. So A-frame itself includes some default tags. The most fundamental one is the entity tag. And so to create an object in your 3D scene, you'll use this entity tag. And then you add these components that, again, add behavior and appearance to it. So one default component that you include is this geometry component. And there's several types of primitives, is what they call it, for like boxes, circles. And then you can add a material component to add color. They have other default components like position, rotation, and scale so that you can move the object around. And what I'll do is I'll go ahead and click over and so drop this in the chat. So we can take a look at the list of components that you can use. So if I scroll down here on the left, here in this left pane, you can see the list of components that you can add to your entity tags. Let's see here, GTLF model. This is the cool one where you can actually add your own 3D objects into the scene. You can add lights, look controls, allow you to control how you're looking at objects. We talked about rotation, scale. What else is interesting? Text. You can add text to an object and it'll place it on there for you. Next thing we'll talk about are how you can create your own components. So those are the default components that are included in the library, but you can create your own. You can use like Three.js JavaScript to create your own component. And so the way you do that is in the A-frame library, we have a method, a global method called register component. And basically what you do is you give a name for the component, you create a property called schema, and this will be the inputs for your component. And then you implement some lifecycle methods to potentially draw using JavaScript. So lifecycle method init is used when you first make a call and the component's added to your scene. This is where the initialization can occur. Update occurs if there's any sort of update to a property, like I say, if you make a length or size change, it'll go ahead and maybe do some drawing that you need to occur. Remove is if you remove the component from the scene. That may be where you want to do some cleanup. Tick-tock are executed on frame updates, so you want to be careful about these two. You don't want to put too much and have too much going on in these. And then play and pause are for animation, so you can actually add animation. There's an animation component, and have it stop or do any sort of re-rendering based on if the animation is played or paused. Should I? Oh, okay. So let me show you an example of that. So, all right. So here's the JavaScript example here using that register component. So in this example, what we're going to do is we're going to create a rectangle of rounded corners. And so this is where I'm using the A-frame register component method here. I'm calling this component rect corners. This is where I'm setting up my input with the schema property. I'm giving these names, the type, and some default values. And this is where I start implementing those lifecycle methods. And I'm using Three.js behind the scenes. So in the init here, I'm creating a mesh here, the Three.js mesh for the rectangle. In the update function, I'm doing some updates to the rendering. I have some standalone methods here for controlling opacity. And I'm not doing anything with tick, but you can see I'm using the remove here to remove it from the scene. And a standalone method actually draws the rectangle and puts some radiuses in there. Now that I have this JavaScript, I'll jump over the component example. So this is my HTML. I pull the A-frame library in. Here's my component.js. That was the file that we just looked at. And then we have the A-frame scene. And then here's the A-frame entity tag. So now that I've created my custom component, I can use it right here. So I've called it out. I've specified values for those inputs. I've also used one of the default components for position to position it within the scene. So now that I've done that, we can check that out. Oh, there you go. Again, this is using the A-frame to create a custom component and create a rectangle with radiuses. All right, so now it's component. So now we can take this even a step further. So we've created a custom component. Now what we can do is we can create our own primitive. So this is now creating our own custom A-frame HTML tag. And so what we're going to do here is we're going to use a method called register primitive. And we're going to create our own custom primitive called aRectCorners. So once we do that, then we can use it in a scene, not have to use the entity tag. So this is a little bit more succinct in putting this into the scene. So the way you do this is you have the call out to register primitive, you give it the name, and then you call your component that we created earlier. So let's see what that looks like. All right, so here's our JavaScript, this primitive.js. This part's all the same. We're using that same RectCorners component. If I scroll down here, I have this register primitive. I'm going to give it this name, aRect-corners. Here's the component name from above. We remember that's the same component name I've given here. And then what I've done is I've mapped those component input values to the primitive values. So once we've done that, I can jump to my HTML file. Again, using A-frame library, I'm calling to that primitive.js. And so now this is where I can use my custom tag or my custom primitive. And then there you go. So you get the same thing here. So since this is the Angular group, I won't go into too much detail about this, but obviously open source web application framework, TypeScript based, which I love, that's TypeScript based. Came out of Google. It's a full-fledged framework for UI and much more, state management, multi-device support. It's component-based and sort of like model view controller-based as well, which I appreciate. Has data binding methods. I like the class or the object inheritance in classes. I'm come from a Java background, so that part I really appreciate. So it works really well. This is probably also a review as well. So component based. So the way this works is we have our selectors, which specify our HTML tags. We specify our HTML file that has some of the rendering as well as with this, the cascading style sheets as well. One other thing that we'll use in this is Angular has a bunch of data binding methods. The one that we're interested in is the host binding, because what we're going to do is we're going to create a model and be able to update based on that model. So let me show you just host binding example that we have set up. All right, so to kind of give you a preview here. So I've created this component here called Thingamajig, and this is a component that we're going to use in our augmented reality, virtual reality scene. We'll end up creating a primitive called a Thingamajig, and it's going to have these properties on here. And then we're going to have this model that has all the properties set. So the idea here is once we make updates to this model, this will get rendered in Angular within the browser scene. And we'll be able to do this updates automatically. So putting that all together, so we showed you how to create your own custom component. We're going to do that. We're creating this Thingamajig component. We're going to then create a custom primitive. And this is the Thingamajig primitive. And we're going to use Angular to create a component to help render it. And then we'll be able to update properties on that component using the Angular host binding. Just some notes, quick notes on Angular and A-frame setup. So obviously, you guys know you can install Angular with the npm install. You can create a new app with this command. And then to install A-frame, you can use npm install to install A-frame. One thing to note is if you want to deploy this to public, you need to use HTTPS. That's for some security reasons, for being able to view the virtual reality or augmented reality on your device. And then after you do that, it's just a matter of creating a scene and dropping in these primitives or these entities or these components. One other thing we'll be using in this example is the Angular state management. So we're using the Angular store. And just kind of quick overview of that. I have the state machine set up right here. So I just have just 4 actions created here. Each of these actions will get triggered to the state machine. So I have an undo, redo, I have an action here to add a thingamajig, and an action here to update a thingamajig. This gets routed to what's called a reducer, which is basically just the state machine. And in the state machine, we have several options here. Here's where we do an add thingamajig. Notice here we were also keeping track of past, present, future as we make changes so we can bounce back and forth. We will create this thingamajig model, and then that will get added to our scene, and Angular will go ahead and render it. That's kind of what you see here in this diagram. Again, we trigger an action, it gets to the reducer or the state machine, runs through a store that I'll show you how that gets called, and then I'll do an update on the UI. So for a little bit more detail here, from our web browser, we're going to be able to execute an action called create thingamajig. This gets sent to that state machine that I created, or sorry, I just showed you. It'll create that default thingamajig model. Using Angular, we're going to have a property panel to show you how we can update to the state machine and then be able to update the properties in the UI. And then that would be reflected in the thingamajig primitive that's being created. And then you'll be able to see this right over here. And thingamajig happens to be Spider-Man. Oops. All right, so let me show you what it looks like in the IDE. So if I scroll up here, oops, sorry, not that one. So I have this Air View Angular component. In it, I have a menu created, and I have just a menu item here for add thingamajig. What that ends up doing is it will call this method. This calls this method on the store, which dispatches this action here, add thingamajig, with some properties. That gets run to the state machine. Then the state machine will update the primitive that you're just about to see here. So let me show you this part. This is the Angular component for a property panel. And this property panel will have the properties for that primitive. So you can make changes to the position, the scale, rotation. And then, sorry, another thing I'm going to show you here. Here we go. And this is a component for our AR view. And in this component, this is where we're registering all the A-frame components and primitives that we're using. So you can see right here, this is where we're creating this A-frame thingamajig. I'm using a GLTF model component, and it's just pulling up Spider-Man. So let's take a look at what this looks like. So I have it running within my IDE. I just launched it. So over here on our left will be our inspector view, and this will be where we'll see the objects. So here's that menu item, add thingamajig. So I'm going to execute that. And that gets triggered through the state machine, and we'll add the object in here. So here we go. We have Spider-Man. Over here, my component panel. I have all the properties for this primitive. So we have, and these are all reflect the A-frame primitives, the default ones. Again, we have a position component, a pitch, a scale. There's some font in here. You can see here at the bottom. Font is a primitive as well with these components. So what we can do is then we can start playing with these components and see the object move around. Change font color. So the colors change there. If we want, we can add in another thingamajig, a different Spider-Man. We can even change it to Morales Spidey. So these are, again, all property components that we can update and get reflected right away using Angular and state machine and see everything here. So the next extension of this is you'd want to be able to make these updates and be able to view these like on your phone or your device. And so, unfortunately, this part is hard to show in this session. So what I'm going to do is I'm just going to paste the link here. Link address. I'll put this in the chat. So unfortunately, this is only going to work for Android phones. But if you go that URL on an Android phone, what you'll see is in your Chrome browser, that it'll come up, it'll show the Spider-Man. All you need to do is click on augmented reality button there, and then accept this permission check. And then what you'll be able to do, as seen here, is drop Spider-Man right in your room. And with Spider-Man in your room, you can get up and walk around. It's part of your environment. You can't interact with it, so technically it's augmented reality. But it kind of shows you the power of A-frame and Angular, being able to render this object in your office or room. And I have some links here. Again, these are in the slides in the show notes, but you'll have links to the WebXR API, Three.js, A-frame, and Angular, and to the code as well, which I already put in the chat. And I think that's the end. So open up to any questions. This was an old show notes. You could win the Star Wars Lego helmet.
I want to ask questions. I'm also I'm playing with my phone to see it in action. Also, I put a bit.ly in case anyone wanted to get on their phone and was having trouble typing that out. That is case sensitive, but then that will go to the link that Jeff posted. What a cool talk.
Oh, thank you. Yeah, it's always kind of a fun one.
Yeah. I know for me personally, I feel like AR and VR stuff has always felt very intimidating and inaccessible. And like, where do I even start? So like, this is great because I now know where I could start. And I kind of had that almost like back in college, like sense of excitement of like a new thing to play with. So this was really cool.
Yeah, absolutely. It's very cool because like, trying to do it in Three.js can be a pretty difficult because there's a lot of code to write. But then when A-frame came along, it just kind of simplified development. And so, yeah, it's definitely easy to do.
Awesome. So yeah, if anyone has any questions for Jeff, please either feel free to put them in the chat, or if you want to, you can just go ahead and unmute and ask directly. There's a lot of great information there, so I'm sure we have a couple questions. And then I also want to mention, like, while we're waiting, see if any questions come in, that I think that some people tend to use things like foo or bar in their demos. I am some people, and I think thingamajig should be the new standard. So That was really cool.
I guess while we're
So
waiting, one other cool thing
yeah.
I'll point out, I think with Apple had the announcement a couple of weeks back, and they had this new feature called object capture, which I thought was really cool. What it allows you to do is take several pictures of an object and create a 3D model with that. So the next extension of that is hopefully they'll have support for some models that WebXR can use. And so that'll make it that much easier, because that's probably one of the difficult things too, is, okay, I want to create this VR scene or this augmented reality scene. Where do I get these models from? And there's libraries online that have these models that you can use, but it'd be great that you can create your own.
So with that, theoretically, I could take some pictures of my dog and then
Yeah,
drop her
if your
into
dog if your
any.
dog will stand still, yeah.
That's a big if.
So with regards to A-frame, I was wondering, especially with the model of like Spider-Man and such, if kind of like if you wanted to animate him or move him in a semi-realistic way, I was wondering if there was some. I'm unfortunately not very familiar with animating things, so I was wondering if there was some fairly straightforward way of adding like a skeleton framework or something to try and, you know, simulate joints or simulate movement in certain places of the model. Or I don't know if my question is.
No, it does make sense. Yeah. So so A-frame doesn't handle that part, the building of the models. It's there just to render the models.
Gotcha.
And so that's where you would have to use some 3D modeling software to create the model.
Okay.
And that's where, like what I just mentioned, the object capture from Apple, where that would just simplify that. You can just take a picture of something and be able to get your model.
Okay, awesome. Thank you.
Oh, I guess one other thing on the animation. So there is a component for animation. And this is the component. So this is just really simple animation. So really this is just kind of moving something in X or Y or Z, or being able to do some rotation. I think the animation you were looking for is like maybe something walking or something. So that's a bit beyond what this can do. But maybe if you had a car that you want animated, this would be an easy way to do that.
Okay, cool. Thank you.
Are there the Spider-Man thing was very cool. Are there any other cool projects that you've done with AR or VR that you can tell us about with A-frame?
Yeah, this is really just an extension of this view here. Sorry, this one. This is kind of just an extension of something else I'm working on, where I want to make it even easier for folks to create their own scenes. So in effect, what I'm kind of building right now is this web-based IDE for being able to create these scenes using A-frame. So right now, you just see a piece of it that I pulled out of my other project to kind of present to you folks.
Nice. For a second, I thought you were going to use the different Spider-Mans to create like an AR version of that Spider-Man meme where it's all the Spider-Men pointing at each other.
Oh, that's a great idea. I need to do that in the next one.
Because you're like, here's one, and then you plopped another one in. I was like, ooh. Nitin's asking if A-frame works with React as well, or maybe if there's a React version.
There isn't a React version. A-frame really is just about the tags and the JavaScript, and then you can definitely use that in React. There isn't anything special about React or Angular, the framework that's used in. Ultimately, it's just the A-frame tags and then the JavaScript, if you want to create your own custom components.
Hi, I think maybe I have a silly question.
No silly questions.
Thank you. So I'm a UX designer, so I know a little bit of HTML and CSS, but I know nothing about this, what you're talking about. So I'm curious, when you are developing, are you developing from a design, or are you designing on the fly? Like, how does it work?
Specifically for the augmented reality and A-frame, you can just do it on the fly. the way A-frame is set up, and I kind of showed you this inspector view here, like you can create an initial scene here and just start experimenting and dropping stuff in and adding these components like for animation or different models or different shadings. So there's no like particular design per se, but you can definitely create it on the fly and kind of just see what it looks like with things around. Does that answer your question?
Yeah, yeah. One of my teams is working on a VR website, and they're a little bit stuck, I think, in terms of like how to do it and like how to work with the developer. So I was just kind of curious what a UX person's job would be in a VR project.
Yeah, you know, and I think a lot of this area is still very new, and the folks are figuring out like what does the UI experience look like in virtual reality. I'm trying to think, I thought there was this example. So you can see here where they're just starting to put in some bubbles, and I've seen ones with menus. Yeah, I've seen one where they have floating menus within the scene itself. And so, yeah, I think right now a lot of folks are still kind of experimenting, kind of trying to figure out what works.
Jeff, do you think that because the AR has that grid pattern on the bottom and then there's like the XYZ axis, that designers could kind of use that to show like, hey, let's place these things here and it should look like this, and we'll place the axis for you in some sort of like mocked, using some, I'm not very familiar with UX stuff, but like using some sort of mocking software. We're like, all right, cool, this is how I want the scene to look, and then the designers could take that over.
Yeah, definitely, absolutely. And then you can already do some of that, again, using this inspector view, because we did a little bit of that before, where again, here's that triceratops. I can click on it, and then this is where I can start moving it around. I can come over here and control rotation, where I can rotate it. So yeah, this is where you can, and then you can also add other objects in here as well, and start kind of creating your scene. And then once you're done with that, you can actually get the code that you've created. I think it's this one. Oh, I think it's this one. I don't know, one of these buttons here allows you to output the final HTML rendering, HTML tags.
These questions all been great so far. Does anyone else have any questions? Again, you can either put it in the chat or feel free to unmute and ask directly. All right, awesome. Well then, thank you so much, Jeff. If anyone want to get in touch with you after, is there any way for them to do that?
Yeah. Okay. Slides here at the beginning. There we go. Yeah, so you can hit me up on Twitter, GitHub, or send me an email at jeff@jeffreyfry.com. Easy to remember.
Great. I'll just pause one more time just to see if we have any other questions or comments, anything at all.
Hey, Michi, this is Ari Waller. How are you?
Oh, hey, good. How are you?
Am I late? No, I'm just kidding. I listened to Jeff. I was on the way back from something. I listened to most of the presentation in the car. What I saw was, though, I think I made a mistake on the slide, and there were two different prizes mentioned. And the way we do it at JFrog, if anyone joined the raffle, is I can't do live drawings for compliance purposes. I actually have to email somebody after someone's randomly selected and make sure they accept the gift. And then we will, of course, share it with the whole community. but we will actually give both prizes away that were mentioned. If any Star Wars fans are out there, one person has a chance to win the Boba Fett Lego set, which I happen to have. If you haven't noticed behind me, I have quite a few Star Wars Lego sets. And we will also give away an Amazon Echo Show. And just as an added bonus, because I really enjoyed listening to the Meetup in the car. It was really cool. Especially in the beginning. I love the format you have. I wanted to, anyone that enters will also be contacted via email, so we can send you a JFrog t-shirt, which we're really well known for. I wear them every day except when the Atlanta Hawks are in the playoffs, which is what I just came back from tonight. So, but anyway, with that being said, anyone can go to that bit.ly and so forth, but I would love to give everybody a t-shirt, and would also love to get those prizes out and make that announcement soon.
Thank you so much. That's so cool. I mean, both those prizes alone are awesome, and then the t-shirt. Thank you so much.
Definitely a pleasure. I mean, what a job, right? I mean, I get to give out t-shirts and Legos and stuff like that. But just really, one of the great opportunities I've had this year by working with a lot of different meetups is just seeing the amazing work that you and organizers across the globe are really putting in especially during the pandemic. So thank you for that. I know it means a lot to everybody in the community. There's a lot of work and organization involved, but I know that you and Julie, just a bunch of the others that support, especially the whole San Diego JavaScript user group, just do such an awesome job.
Thank you. We really appreciate that. And it's really nice for the attendees to get something, because we also appreciate everyone that's still coming out to the Zoom meetups. The Zoom fatigue is real. And so it's great to also get a little something for them.
So glad.
Thanks, Ari. And you can see that stash of toys behind him too.
Yeah. that's my collection. They're not for sale, but many have made it to a meetup raffle for sure.
That's great. I love it. All right. Well then, thank you so much. I'm going to stop the recording.